Hello, my name is Andres Blanco, and I'm here to talk about 802.11 protocol. And in this presentation, I want to show you that people think that if you don't have an attack for WPA or WPA2, or you don't have a new attack to gain access to a network, they think that the protocol is like secure and there's no entry points or no attacks. But I think that this is not correct. And there are a lot of new things on the protocol that an attacker could use to gain access to a network or devices that are connected to a network. So for this presentation, I will talk a lot about frames of the protocol. So it's important to know that there are three different types of categories of frames: management, control, and data. And in this presentation, we are going to focus on management frames. These frames are used on the scanning phase and when the devices are trying to connect to a network. And for example, the beacon frame is used to announce networks. And it's important to understand that all these management frames are not encrypted, and anyone that is doing monitoring can gather information from these frames. The other term that is going to be important to understand in this presentation are that we have two different types of network interfaces. We have soft MAC interfaces that they manage all the MAC layer of the protocol in software. This means that the driver or the kernel module or kernel extension, depending on the platform, is manages the MAC layer of the protocol. And then we have full MAC interfaces that they manage all these layers in the firmware, in the hardware. Okay, so this type of interfaces, for example, Broadcom has a lot of website chips that use this type of MAC, full MAC. And for example, all the iPhones use this type of interfaces. So a lot of things happen in the firmware and not in the OS. This is really important to understand from the attacker perspective, because these last 2 weeks, if someone saw in Project Zero of Google, they released 2 vulnerabilities for this, for Broadcom firmwares that affect every iPhone or every Apple device, mobile device, and there are a lot of attacks on this part of the layer. So I'm going to explain further in the presentation more about this, but it's important to understand that if you attack the firmware, you are outside the OS. So everything you do, the OS has no way to know what is going on the Wi-Fi chipset. Well, another key concept of the presentation is the management frame structure that is called information element. So the information element is a structure that is used on all management frames, and they are present on beacon, pull request. Everything in management has this type of structure. It's a really simple structure, type length value structure. So it's really easy to understand. For example, we can see the SSID information element, that every time you are scanning for a network with your Wi-Fi mobile device or anything, you're going to see that the name of the network is present on this information element. Okay, it's a really easy structure, nothing weird. But then we have structures like this one, that they are much more complex. This is the RSN information element that is used for networks using WPA or WPA2. And this information element describes the capabilities in the WPA and WPA2 network. Okay, so here we have something that has no sense. We have the SSID that has 1 byte for the type, 1 byte for the length, and then we have inside another structure that is the RSN structure, and it has here 2 bytes to define a count item inside. So the information contained inside the information element can be more long than the information element that is contained in it. So this has no sense at all. Well, this was a vulnerability I found in 2012 that was in these Broadcom firmwares. So I was able to send an authentication key count item with a size much longer than the information element. And when the Broadcom firmware was processing this frame, it crashed the firmware. So there was no way you can use Wi-Fi in this situation, okay? And this attack can be only sent to a specific device. So you can do a Wi-Fi denial of service targeted to a specific device. I'm going to show a demo of this. So here we have an iPad. I'm going to enable Wi-Fi. When I enable it, the device is going to scan, and the firmware is going to process all these frames and then send to the kernel extension the information about the available networks. So now I'm going to stop disable the Wi-Fi to show that now I'm going to start sending the malformed the frames to the device, and once I now enable, the kernel extension is going to try to initiate the scanning phase on the firmware. The firmware is going to crash and restart all the time, and the kernel extension is unable to get any information from the firmware chipset. So we are breaking, the OS is going to work completely like well, nothing is going to happen, but the firmware is crashing all the time. This is not a really interesting bug because it's only a denial of service, but the thing here is, let me grab the window here. The issue here is these last 2 weeks, Project Zero released 2 bugs in the same firmware, okay, but they were remote code execution. So now they were able to execute code inside your firmware. And everything you do about in your Wi-Fi device, on your Apple, on your iPhone or iPad, is going to go through this Wi-Fi firmware that has been compromised. So your network connections, you're not going to be able to trust anymore. So I think that these type of attacks on these mobile devices are going to be increasing all the time because the protocol is getting complex every year. So I think the attack surface is expanding. So now we'll talk about a little bit about information disclosure and devices that are sending information to anyone that is nearby. To be clear, I'm not going to talk about, for example, here in the hotel, they are using an open Wi-Fi. So everyone is connected to your Wi-Fi here open. If you're not using a VPN, all your traffic is going to be plain. Okay, so if you use unsecured protocol, I don't know. We now use, everyone is using HTTPS, but if there's an attack or something, you're going to be insecure. Okay, so I'm not going to talk about that. I'm going to talk about devices that they are leaking information even if they are using a secure network, okay? You're using WPA2, but some devices, they are leaking information to anyone that is nearby. The first thing I'm going to talk is about Cisco Client Extension. That is a protocol for Cisco enterprise devices, okay? So these Cisco devices are connected. For example, in this hotel, I don't know if they use Cisco, but if they are going to have like 100 access points, and they are all controlled by a controller that is called WLAN controller. Okay, and this device controls all the devices. This controller has support for CCX, that is this protocol, Cisco Client Extension, and this is part of the documentation. So this is a feature for the device, for the protocol, that says that these access points are going to send some information elements on management frames with internal network information in plain. So this is a feature, remember, it's not a bug. So this, for example, is a beacon frame that has this CCX information element, and we can see here the access point name. This access point is provided by the IT management that handles all the network or the Wi-Fi devices, and usually they are leaking some sort of topology network information, okay? Then we have the number of clients connected to access point. You can get this information, the number of clients connected to access point, by analyzing all the traffic that is in the air, but this is much more easy. I get the information from the access point. It's saying me, okay, I have 17 clients connected to me, okay? This is really interesting because I always want to target the access point that has more clients. I don't want to target an access point that has no clients at all. But the thing, well, here, for example, we get topology information. This is 3 beacon frames. The interesting thing here is that they are not sending the network name into the air, okay? They are not broadcasting the SSID, but because we have this information element from Cisco, we can see here that there's an access point called Simpsons, other one Beetlejuice, another one Men in Black. So these are access points that are in Universal Studios. So we can get information from where the access point could be or what section of the network they are plugged to. And then there's another thing that the protocol specifies is that they will send in plain text the IP address of the controller to anyone that is not even connected to the network, okay? So you are leaking internal IP addresses to anyone that can process this frame. Again, these frames are not encrypted and they are sent to anyone. In this case, it's a little bit more difficult to grab this frame if you are doing passive monitoring, because this frame is a reassociation request, reassociation response. So when you are moving around a network, your device is always trying to connect to the access point that has better signal. So when you're doing that, you're always doing reassociation, okay? So if you have a device that supports ECX, and when they try to reconnect or reassociate to another access point, it would send this reassociation request, but this ECX feature, and the access point will return internal network information in this frame that again is unencrypted so anyone can read it to anyone that is around. So I think that this is a really bad feature because I don't understand when they are leaking to anyone internal network information. But again, it's not so easy to find this when we are doing passive monitoring, okay? Because we need someone trying to reassociate to a network that has support for this protocol, that most devices don't have this. But I start thinking, maybe I could send a fake frame. I send a frame trying to reassociate, even with a MAC address of a device that maybe hasn't been associated to a network in the first place, and I will send the information that I get from the beacon frame, and I will be able to get these IP addresses from the internal network. But I was thinking this shouldn't work because we have a protocol state machine that should avoid these type of things. I'm being on a station that I haven't been connected to a network, and I'm trying to reassociate. And to reassociate, I should be associated in the first place. So this shouldn't work, but it works perfectly. So you can do this, and you can get, here we can see the MAC address from the fake frame. Here we can see that the access point is saying that the reassociation process was successful. I don't know why, but it shouldn't be like that. And here below we have the IP address from the wireless LAN controller of the network. Again, think that if you have, for example, some networks that you have a public network that has an open network so anyone can connect, like a guest network, and then you have a private network, they are going to share the same wireless LAN controller. And having the IP address is really interesting because you can target after you are connected to a network. So now I'm going to talk about Wi-Fi Alliance, that is a non-profit organization that has released several specifications that runs on 802.11. In this case, I'm going to talk about WPS and Wi-Fi Direct. So WPS is a protocol that many of you should know it. It's a protocol that has been attacked a couple of years ago with a pin brute force attack. WPS gives you the capabilities to set the security of a network easy, like in an easy way. But I think that they do it in the worst way they could, okay? Because they give you two options. For example, let's say you set your network with a really long passphrase, so anyone, you are not able to crack the network key or the passphrase for the network. So you use this PIN number so anyone can connect to your network, so you don't have to share this long passphrase, okay? Just only saying that words, I understand that this is the worst idea you can do. So a guy read the specification and notice this, that it was even a note below that says, once this has been implemented, it could give an attacker the possibility to do a brute force attack on the PIN. And the PIN is only 8 digits, okay? So you put a passphrase for 64 bytes, and a guy using a PIN of 8 digits is going to be able to access your network. So really bad idea. And then there's also a tag that is called a push button. That is, for example, I want to connect to my access point, so I go push a button on the device, then I go and push a button on my mobile device, and they are going to connect, okay? It looks pretty cool, but again, race condition everywhere. I go and press first in the access point, and if someone is listening, it's going to try to win the race before my mobile device and get access to the network. And again, if I push first the mobile device, then someone could be listening and could impersonate the access point and gain access to my mobile device. So this protocol is a piece of shit. Like, sorry, but I have to say it. There's nothing good about it. But I'm not going to talk about how to implement these attacks. I'm going to explain that besides that, these access points are leaking a lot of information about the device in the beacon frame and the proof response frame, sorry. So when you put this, when you have enabled this feature on your device is going to say, okay, I'm a Netgear device, I'm this model, this is my model version, and this is my serial number. This serial number is fake, but this gives a lot of information. So if you have a vulnerability for a device, fingerprinting it and being able to know if this is a vulnerable device is only listening one frame in the network. Okay, so getting all this information is pretty easy. Some vendors like to send the real serial number of the device in the frame, so it's easier to have a unique ID for the device. So thanks Cisco for the good implementation of the protocol. And is there a way to avoid this? Is there a way to not send all this information with the devices supporting this protocol? WPS is almost in every modern Wi-Fi access point. Maybe on the enterprise level access point is not enabled, but all other access points have this support for this protocol. So is there a way to disable this? Well, I disabled it on my access point, and then I start listening frames again, and it doesn't work. It's funny because it will go to the structure that is sending all this information from your device, and it will put, okay, I have disabled the protocol. With WPS state, it's not configured. It says that it's not configured, but it's still sending all this information. So maybe you are protected from pin brute force attack or push button configuration, race conditions, but you will be, again, leaking all our information that could be used for other type of attacks. Then we have Wi-Fi Direct. That is another interesting protocol. It's not so known in the industry, but if you have a smart TV or a printer, they are putting this everywhere nowadays. The first device that implemented was the Android mobile devices. So Android have support, I think, from 2012 or 11. And again, devices that they have support for this enabled by default will be leaking a lot of information. And why is it? Because it was developed, again, by Wi-Fi Alliance. And Wi-Fi Alliance decided to use WPS to provide security to the protocol. So again, Wi-Fi Direct using WPS, they send again all the information from the device. This is a media center that is saying to us the serial number, the version, and a lot of information. We're going to see that this protocol is not only about leaking information. At the end of the presentation, I will show you that this protocol, bad implementation of this protocol could give access to devices. Okay? So, information elements for everyone. Why I put this title? Because vendors always like to put their things in the protocols. They like to extend the protocol and add things. Here we have an HP information element from a wireless printer. Okay? But if you're looking traffic with Wireshark or other software, it's only gonna, it's enabled to process this information, so it's gonna show you like an array of bytes. And it doesn't look too bad. It's like, okay, HP printers are sending this information, but it doesn't look too bad. But it's pretty bad because they are again sending information of the state of the printer. For example, if the printer is connected to a wireless network, if the printer is connected by USB, it sends the model, the serial number that is real, and the IP address of the network they are connected to. So again, they are sending in management frames IP addresses of network that they are connected to. Again, they are leaking too much information. Then we have, for example, iOS devices. In this case, this is an action frame, a management frame from an Apple TV. Apple TV, this is a funny case because Apple was one of the first to implement MAC randomization to protect devices to being traced. And here, as we can see here, in the transmit address, is a MAC address that is randomized. So if I grab another frame from this device tomorrow or in a couple of hours, it's going to be different. So I'm not going to be able to trace it. I'm not going to be able to know if it's the same device I saw a couple of hours ago. But if you send a frame that has the real MAC address inside the content of an encrypted frame for anyone to read, MAC address randomization, you broke it, like yourself. You implement it and then you broke it at the same time. And not only that, they also send the real MAC address, the model of the device. In this case, is an Apple TV, I think here, an Apple TV 3. And it also sends the name of the device. Again, remember, this is all an encrypted management frame that you don't have to be connected to anyone, to any network. This is sent to the air so anyone can read it. And the same thing was also happening on iOS devices using AirDrop protocol. I don't remember if I mentioned this. This is AirPlay protocol, and there's also AirDrop protocol. AirPlay is used when you want to mirror, for example, your phone or your Mac on an Apple TV. And AirDrop is to connect devices without the need of connecting to a network, to an access point, so devices can connect between them. It's pretty similar to Wi-Fi Direct, but for Apple, because Apple doesn't support Wi-Fi Direct. So iOS devices have the same issue. I think that at some moment after iOS 9.3, they fixed it. So now they are not leaking the not randomized MAC address, and they put the randomized MAC address inside the frame. But they were sending the real MAC address inside the frame. So MAC randomization was implemented and broken at the same time. And they are also leaking the name of the device. So if you want to target someone, you can see these frames that they are injected into the air, and you can know whose device is it. Okay? And just to mention that there are a lot of more things to see on these protocols. This is an information element from a Samsung device. I found one day I was doing somewhere driving, and I found this. I noticed something weird. I start seeing, and I say, too much information. This information element is too long. It has too many bytes. Let's see what is going on. And I start seeing these type of things. This is an IP address. So this device, again, it's sending IP address of a network they are connected to. Remember, we are talking devices that they have a thing that is called dual mode. Okay? I have a device, for example, a smart TV, that can be connected through Ethernet or through wireless to a network. But besides that, they are also providing this Wi-Fi direct interface, so anyone can connect to the TV, and the TV is also connected to another network. So it's not easy as I connect to a Wi-Fi and I only have a connection with one device. Nowadays, devices support multiple connections with multiple devices, making a really good environment for pivoting and gaining access to another networks when I'm attacking one device. So I will show you, this is not a really good demo because I was unable to gather too much information around the hotel, but I tried to go around the hotel and to see if I found devices like these ones around us. And I will show these ones. Let me see if it's too small, no? I don't know how to see if I can. Let me see if I can make it bigger. Someone knows how to create a bigger font here in the editor? No? Let's try to do it with a shell.
Yeah.
Yes? Sorry, I missed this. So here the first one. Let me see if we're at the top. No. The first one are CCX devices. So here I found near the hotel some Cisco devices that again they are protected using WPA2. They are not broadcasting the SSID, so I don't know the name of the network, but they have a particular access point name that we can see below. They are all belong to the same network, okay, because they are using the same format for the name. We can see here some IP addresses from the internal network that they are from the wireless LAN controller. So again, this was gathered only going around grabbing management frames, okay? No attack to the network, only passive traffic capture. Then, this was a really bad choice to do for a demo. I'm sorry about that. Then we have, for example, these devices that they are WPS devices that they are sending a lot of information. For example, the manufacturer, TP-Link, Netgear, the model of the device here. This in particular has a lot of bugs. And this Cisco, for example, here. So all this information for your work driving is really useful to gather information of the networks. This one right here are this is Wi-Fi direct devices. So here we found a TV here. This is a Samsung TV. This is I'm not sure, but it's a here Windows PC. So it's a Wi-Fi direct device that is running on Windows. Or sorry, it's a Windows machine having support for Wi-Fi direct. Then here we have another one that is a printer, a brother printer. Printers are really interesting because they are usually really unsecure. Then here we have more information about the printers. This is some HP printers that they are here around. For example, one that is open, so anyone connect and send some print jobs if you want, or scan some documents. And this is not connected to any network, but it here says that also USB is not connected and it doesn't have an IP address. So what is that printer for? It's not connected to anyone, not USB, no Wi-Fi. So maybe this case, I think that it could be connected through Ethernet, okay? So this is connected, but not by Wi-Fi. Here we have another, this one is protected by WPA2. We are going to talk about that later, and has an IP address from the internal network. So again, all this information, I only take some examples, but there are a lot of them. And I only walk, okay, went 2 blocks and go back 2 blocks. So if you go through Miami, you're going to find a lot of these devices. Things will get better, will get worse at the end of the presentation. Not for us, for other people. So another interesting topic is the architecture, okay? So when we talk about Wi-Fi, we usually think that everything is implemented on the driver, so everything is in the kernel. That is not true. So this is an Android architecture, but in iOS we have something similar, and every platform has something similar to this. We have a firmware that handles a part of the protocol in the chipset of the wireless network card. Then we have the kernel, that could be kernel extension, kernel driver, or anything kernel module. And then in the user LAN we have the WPA supplicant and the Android framework. So the complex thing here to understand is that not everything is handled by one thing. Okay, so we can have a frame that first is processed by the firmware, and the firmware can do something about it, modify it, or block it, or do something about it. Then it's going to go to the kernel. It could happen the same thing. Then it's going to go to the supplicant. And finally, something or part of the information will end up in the Android framework. Okay? So a lot of different vendors and a lot of different persons are touching all these frames in different layers of the protocol. And this could make things really messy. This was the case of another bug I found in 2014 that I think it was the first bug that was able to crash the Dalvik VM with one frame, okay? So I sent a frame, the frame was parsed by the firmware forwarded to the kernel forwarded to the supplicant parsed it, processed the frame. It was a malformed frame, so the supplicant ended up sending a malformed event to the Android framework. The Android framework processed the malformed event, send an uncaught exception. This uncaught exception was not handled by anyone, so the Dalvik VM decided to restart. So again, this was not a really amazing bug, but it's a good example of how complex the platform is and how you think that maybe the frames are only going to be processed in the kernel side or in the firmware side, and that's not true. Okay, the frames are processed in different layers. And in this particular case, also something interesting is that the supplicant and the Android framework, they are usually the same in all devices. So you're not depending on a specific firmware or kernel extension or kernel module. So I'm going to show you a demo of this attack. So we here have three different types of devices. We have a Samsung phone, a Samsung tablet, and a Motorola phone. The three of them are using different type of Androids, and the three of them have different Wi-Fi chipsets, okay? Different cards, different version of Androids. But the three of them were vulnerable to this attack. So I'm scanning for Wi-Fi direct devices, and once I start sending the malformed frame, the Motorola is the first one to go. It started restarting the Dalvik VM. It looks like it's restarting the whole device, but it's only restarting the Dalvik. Here, this one is also restarting. And finally, the Samsung tablet, it will restart a little bit later. This is happening because I'm injecting the frame on one channel, and devices are, when they are in the scanning phase, they are hopping through the channels, and when they encounter this frame, they crash. So again, this one is not so critical bug, but it's a good example of the complexity of the layer of the protocols that are inside the OS, the protocol itself, and for example, the firmware and kernel are unable to process this frame, so they say, I don't understand what this frame is, so I'm going to forward it to the next layer, okay? So sometimes they end up forwarding malformed frames to the several layers that they are afterwards. So now I'm going to talk about Wi-Fi direct implementations, the bad ones. That there are a couple of them. And we're going to see that this one, the first one is funny because I bought this device to use at home, and I have it for 1 year. And once I was looking around, and I said, this is completely broken. So for 1 year, I was completely vulnerable to someone gain access to my protected network that I have a passphrase like 64 bytes that I don't remember myself. So I have to calculate it to gain access to my devices, and every time I want to connect another device, I say, use 3G or 4G, I don't care. Don't connect to my network because I don't remember my password. So using this device, they could gain access to my network because this device has a bad implementation of the protocol. So again, Wi-Fi direct, enabled by default, you plug it you take it from the box, you plug it, and factory default, Wi-Fi direct enabled by default. This device has two ways of connecting to a network. One is Wi-Fi, and the other one is using an Ethernet plug. So any way you connect this device to a network, if you have Wi-Fi direct enabled, even worse is that I wasn't able to understand how the protocol is being disabled, because I disabled a couple of times, and then a couple of months later, it's enabled again. So I don't know what is going on with this device. I think I'm going to throw it to the trash because... So the thing here is, I forget to mention here, sorry, it's not only enabled by default, because enabled by default of this protocol is not really a problem in itself, because a lot of devices has the protocol support, and it's not a problem. because they authenticate the devices or they handle the connection in some way, so you have to allow the device to connect to you. In this case, they decided that trying to get user authentication or user notification of someone trying to connect to the device, it was something that it was not right. So they say, no, we are going to take this part, and if you want to connect to the device, this is not require authentication nor notification. So you are maybe playing a video on your home or seeing a movie on your device, and someone is connecting to your device, getting access to a lot of services that the device provides. For example, it provides an Apache HTTP server that has a website full, this is really full of OS command injections and bugs that the vendor doesn't care to fix. And also it has Samba. So if you have a flash drive connected to the device, you have anonymous read and write permits to write on the device. So it's really bad for me because I have the device at home. Sorry. So I'm going to show you a demo of this. So here I have the setup. I have my screen with the device connected through HDMI. I have the device connected to my wireless network, okay? And I have a flash drive plugged into the device. Now I'm going to show you that the device is connected to my wireless network. I'm going to test the connection. It says that connection is okay. Again, remember, this is connected through Wi-Fi to my wireless network. And now I'm going to see if I protect it. I'm going to check if the firmware is up to date to see I don't have any bugs anyone can abuse. The device is up to date and it hasn't been fixed, and the vendor doesn't care, so it's not going to be fixed. Now the thing I'm going to do is I'm going to use my computer, that is the one below, and I will use the WP supplicant, that is the tool to connect using Wi-Fi direct using Linux machine, and I will initiate the client and I will scan for available Wi-Fi direct devices around me. In this case, the only one I want to find is this device. I don't know if it's really, can anyone read this? Yes? Yeah? So I do a peer-to-peer find, okay, to find devices. Once I find the device, I'm going to grab the MAC address from the device that supports Wi-Fi direct, and I'm going to use the command peer-to-peer connect using the push button configuration you remember I talked before. And we are seeing here the screen, okay? The screen of the device is not showing anything. I'm connecting, the device is connected now. Nothing happens. So if you're using this device, you will never notice someone is connected to your device. And now I'm going to ping the device to show that I'm connected to the device. So I'm connected to the device, and the device is connected to my wireless network, okay? And now I'm going to open a Ubuntu Samba client, and I'm going to read the files that they are in the USB flash drive connected to the media center. I'm going to see what it contains, and then I'm going to write a fake movie file to show you that then the device is going to update the library of the device of the movie files that has inside the flash drive, and it will show you that we have written on the flash drive. So I'm there making a fake file that is called fake MP4, and then I have to wait a couple seconds, okay, so the device notices that something changed on the flash drive and has to update the library that it used to see the movies. So I'm gonna go to the video folder, and this is the movie that was already in the flash drive. I have to wait a couple of seconds, and then we are gonna see that a new file appears there. I'm playing around to see, only to show you that the device is working, and there is updating the library, and it will show the fake video that is there. So again, this device, it was connected to my network. So maybe you think, okay, I don't care about the flash drive connected there. Maybe if you take it and connect it to a machine of your own, maybe you should care, but let's say you don't care about that. You have a device that is connected to your network that knows your key of your network, and there's full of vulnerability once you are connected to them. And you say, okay, but no one has access to connect to my, yes. Using Wi-Fi Direct, anyone can connect. Anyone that is nearby can connect, and you will never notice that someone can connect it to you. The only way to notice someone connected to you is opening the device, plugging some cables to the UART port, putting that in your computer, and then seeing the shell that the device gives you. It's the only way to notice that someone connected to your device. And again, this is by default. So you could tell me, okay, but it's a media center. Who has this in a company or enterprise or some more interesting target? Because you're going to see the videos of someone that has, I don't know, downloaded a movie or something. But that is not the case when we talk about HP printers. HP printers, they also have implemented Wi-Fi Direct. That is a really cool feature because you can go with your phone and print something or scan something. But they implemented, I think, the wrong way, okay? They thought that it was really important to give support for iOS devices. And because iOS devices doesn't have support for the Wi-Fi Direct, and I think that HP, they didn't want to buy, I don't know, the specification or the support for AirDrop, or Apple don't want to sell it. They say, okay, we should like implement something that has support for legacy devices or devices that don't have support for Wi-Fi Direct. So they say, okay, we should put an access point directly there so someone can connect and print the things that they have to do, the documents that they are really important. So if you go around, again, looking around the city, you will find a lot, but a lot of these printers around. Some of them you can see here that they have, for example, open networks. So not that only can anyone monitor the traffic that is going in plane and know what people is printing or sending print jobs or scanning or doing a lot of things. They say, okay, this was really bad. We should think about security. We should think about implementing WPA2. So nowadays, by default, they implement WPA2 with a default password of 1, 2, 3, 4, 5, 6, 7, 8. Yes, I don't understand how they think about this, and they say, no, we should implement something secure, and they put a default password on every printer, okay? And there are a lot of printers. Again, remember, some people unbox the device, plug it to the Ethernet, and they say, okay, we have a network printer, great, we have a network printer, and they leave this for anyone to use. And that's not the only thing that we can do with the printer, because remember, the dual mode, so we can be connected with the printer to a wireless network or an Ethernet network at the same time giving support for Wi-Fi Direct. So a guy that connects through Wi-Fi Direct, knowing this default password, or in the case that the network was open, anyone can connect. They will have access to this beautiful embedded web server that has no authentication at all. No authentication. So you can do a couple of things with this. That is not the only service they provide. They provide, as I mentioned before, printing services. You can scan. You can do a lot of things. So there are another lot of services you can use to attack the printer, and again, use it like a pivot to gain access to the network the printer is connected to. So the attack doesn't finish when you access the printer. Okay, you should again use another service to gain access to the network. I think I'm forgetting something about this. Well, if I remember later. So one interesting thing about this bug, it was that I tried sending a lot of mails. I know that some people, I don't know, Nico, where are you? Reporting this bug. I tried to send several mails to HP. HP didn't reply, not to even one. And a month later, they released these videos of Mr. Robot hacking printers with a phone and hacking, I think, Xerox printers, and said, if you don't have an HP secure printer, you are going to be owned, something like that. And this was released 1 month later. I was trying to release the same vulnerability. With your phone, you can connect to the printer, access all these web services that it has, One of the web services lets you disable the firmware updates. One web service lets you set a proxy for the printer. Another web service lets you, I don't know, proxy, disable the firmware updates. You can see all the emails that are stored inside the printer. You can access all the emails that are stored inside the printer. You can even, in some models, read part of the memory to see what shops were printed. So it was funny that they hired Chris Translator to do this video 1 month later that I tried to report it. And the final thing I'm going to talk, I don't know how much time I have, but this one hasn't been reported yet, so it's still in process, but you can have fun with it. It's about Samsung Smart TVs. So Samsung Smart TVs has Wi-Fi Direct, again, by default. But this one, they're thinking more about it, and they say, okay, we should give some authentication to the user, okay? Or you shouldn't be able to connect to the device, and the owner of the TV is not going to be able to notice you are connecting to. So it shows you this type of message on the screen, saying, tablet device is trying to connect, and you can allow or deny it with your remote control. We know that the remote control is really a secure device that cannot be impersonated by anyone, so it's pretty secure. But besides that, once your device is connected to a network, it will show you this message that is not really clear. It says tablet is now connected. Let's think this. Once your device has been authenticated for the first time, it's not going to be authenticated anymore, because the TV implemented something that is not specified in the protocol, but they do it so the users don't have to suffer every time they want to connect with the device. So they implemented a whitelist and blacklist. So once you put allow to that device, your device is whitelisted. So every time it connects, it's going to show you this. Tablet is now connected. Let's suppose your device is called Smart TV. So it will show something like Smart TV is now connected. It doesn't say Wi-Fi Direct, it doesn't say anything. So it's not clear enough so anyone notices what is going on. This is the whitelist and blacklist method they use. It's a multimedia device manager that they have there, and you can have the allowed and denied devices. But someone remember, like, I don't know, 10 years ago, when people implemented MAC filtering, like a secure method of authenticating devices to connect to a network, and you think, okay, no one is going to implement this again. It's stupid. Everyone knows that MAC address is going to the air in plain text, and anyone can read it. So it's not secure at all. Well, Samsung went to the cemetery and revived that method, and they implemented it here. So you can connect with any device. You only have to be monitoring the traffic. Once you see a device that is connected by Wi-Fi Direct, you can then disconnect this device, copy the MAC address, put it in your Wi-Fi card, that is one command, and then connect, and you will be connected. You don't have even to use the same name of the device that was connected the first time. So you can change the device name so the notification message doesn't make sense, and someone seeing the TV will never notice what is going on. And this notification message, it stays in the screen for 1 or 2 seconds. So it's really. And once we are connected to the device, again, we have a lot of services we could exploit and gain access to use the TV to pivot to the network that is connected to. I think 2 or 3 days ago, a guy presented in a conference, and he said that he had like 40 0 days for Samsung TVs. Okay? If you grab one of those 40 for a network service, that's all you need to use a Samsung TV that is connected into an enterprise network. And besides all the protection the network has, you're going to be able to connect to that TV and pivot and gain access to a network. So nowadays, every device that is connected to a network, it turns to a potential entry point to a network. It doesn't matter if you have really good access point with a lot of security implemented on them. Okay, so I'm going to show you a demo of this attack. Again, remember that this is not reported yet and it hasn't been fixed, so please do a correct use. You can test it on your TV. So first I'm going to show you that I'm going to do software updates. And there's no updates available. I have to say something. I recorded this, I think, 1 or 2 weeks ago. This weekend, before I was coming here, I saw my TV showing me a message that something's update was installed or something. I panicked. I went there, tested. No, it's still there. So, no, hasn't been fixed. So, no updates for the TV. The TV is up to date. Now I think I'm gonna show you the multimedia device manager, showing that I have no device connected to the TV. So no device in the blacklist or the whitelist. And I will grab I think it was my tablet or something, and I connect to the TV. I set my Wi-Fi direct name to legit device, so it's easy to understand that it's legit. So it's okay if I allow it. So once I allow the device, I think this video I recorded too slow. That is the notification message. I think it was 2 seconds. And again, it's just saying legit device is now connected. I don't know what it means. And now I want to show you that the device has been effectively added to the whitelist. It's been, here it says allowed. So now I'm going to grab my computer that was in the same room. I already get the traffic. Again, it doesn't matter if it's encrypted or not, because the MAC address is in a part of the layer of the protocol. It's not encrypted. So I grab this, and I put it on my computer, and now I'm going to use Wi-Fi, again, Wi-Fi Direct using WPA supplicant, and I will connect. I will change the name so it's easy to see that I'm connected with other device. Connected to Evil device. Evil device is now connected. So that's all. Now I have access to the TV. So you only need a MAC address to connect to the TV. I will show you that this has been updated. Now it says Evil device, because again, the whitelist is updated with the device that was the latest to connect. So the only thing they use is the MAC address. So the name, it doesn't matter. So you can put any name you want and you will be able to connect. And again, Wi-Fi direct traffic is really easy to see on a capture. So if you are capturing traffic, you are going to be really easy to identify what is Wi-Fi direct traffic. So So this was the last demo. I'm going to talk about some conclusions I have about this. Is that Wi-Fi, it says that many people says, if you don't have a practical attack on the WPA2, you don't have to be worried. The network is secure, no one can access it. No, it's a lie. Attack surface is extending a lot. There are a lot of new protocols. Devices are supporting a lot of different ways of connection. If you don't know this, you're not going to be able to see them. You need to use different devices or different tools to get access to this information. And remember, all the structures we've seen, Wi-Fi Direct, WPS, CCX, all these processing of structures is inside some place in the protocol. It's inside in the kernel or it's inside in the firmware. One of the vulnerabilities that was released I think 1 week ago from Project Zero was a Broadcom firmware vulnerability, remote code execution on a lot of Samsung devices. That was because the CCX information element we saw before. Also, that information element structure, a little bit, it was not so complex, but a little bit complex. It could be used to exploit a firmware of a new device. So all this complexity is getting into somewhere in your device. So attack surfing is extending. Is good. It's really a good thing to know. Fingerprinted devices is really easy. You just have to put your network card in monitor mode, start going around, and you will start seeing Apple TVs and a lot of devices that they are there, again, available for anyone to connect. If you have an Apple TV on your home and you have AirPlay enabled, that is by default enabled, and by default is also enabled without authentication. I didn't talk about that, but That is something interesting. If you have that, anyone around you can know that you have an Apple TV. It will be able to read the name of the device. It would, so fingerprinting devices, and I'm not talking about access point. I'm talking about access point, TVs, printers, notebooks, netbooks. All the devices are now easy to fingerprint. And that is something that we should see more. This is also a really important thing is, as I explained on the platform architecture, there are a lot of vendors grabbing and touching the frames. So there are a lot of vendors interacting with the frames. For example, in the graphic I showed before, we have a Qualcomm that was in the firmware and in the kernel, handling the frames. Then we have the WPA supplicant, that is another guy developing that. And then we have the under framework. And in other devices, there are more vendors, okay? That even some vendors, for example, Apple, ask Broadcom to put some specific code into the firmware to handle other protocols, for example, AirDrop or AirPlay. So again, too many hands in the same code is not a good thing. No, sorry, it's a really good thing. And then we have bad implementations. As we saw, there are a lot of implementation around us, Wi-Fi Direct, WPS. There's also one that's called Hotspot 2.0, AirDrop, AirPlay. There are a lot of them. Some guys grab the specification, they implement something as the implementation says, and they then start modifying things to work as they want. For example, Samsung TV applying whitelisting or blacklisting. And they sometimes take bad decisions. And network access. As I say before, usually when you are protecting a network or when you are targeting a network, usually focus on access points. You say, okay, if I want to access a network, I have to attack the access points. That is not true anymore, okay? If someone in a company buys 10 Samsung TVs and put it everywhere, and, oh, I want to show some slides. Let me connect using Wi-Fi Direct to show you the slides. Now, you just put another endpoint to your network only because you are using a feature that was bad developed or bad implemented. And lastly, I have to say that this is only a couple of things. There is plenty much more things to look into, okay? So I was the guy that it was, if someone was using your phone and you saw a lot of shit on the Wi-Fi, it was me to gather a little bit of attention. But, so this is only one thing, okay? There's a lot of more things. We haven't been, I haven't seen yet attacks on AirDrop and AirPlay, besides one attack that was, I think, 2 years ago, that shows how a guy using AirDrop was able to install an application on an iPhone without any user interaction, okay? So these attacks are here. We should be looking this. This is my GitHub account where I have some code with some of these demos I show you. And this is my contact. And if someone has questions, I will be happy to answer it.
Okay, we're going to give you the mic.
All right. You mentioned that the protocol itself is not the vulnerable, but the problem was the implementation. So you just show us the Cisco devices. Have you tried this same thing with the end user devices like, you know, Netgear, Asus, or any other stuff? Do you see the same pattern among all those devices?
What protocol?
WPS.
WPS?
Yes.
Yes. Different vendors end up implementing like fixing things, okay? When they notice the pin brute force attack or the push button race condition attack, they start making modifications. But that is the funny thing, is every vendor take its own decision. So in some devices you have one way, in some others you have another way. Something I didn't mention before is WPS pin brute force attack. It was fixed, but then appears a lot of other vendors that make a poor decision on how they they calculate the first pin that is inside the device by default, and it was easy to replicate. So gathering the MAC address and some other things of the frames, you were able to get the pin. So again, you didn't need to brute force anything. You have to do some calculations and you will get the pin. So it's a little bit crazy to understand. Every vendor is doing his thing. So.
Yeah, hi. I'm Skyline. I do a lot of browser fuzzing and find browser bugs. So one thing I found as well is that you can, in a browser, you can scan the local network. And it would be really nice if you have an O-Day, not to waste it on anybody that you don't want to target. So one thing would be you first scan the local network to try and figure out whether that's the network you're trying to target. And I'm thinking with this thing, you could walk into an office and scan the network, figure out like at which IP certain printers are, and then do the same if someone in that company is like visiting your attack site. Scan the network and see if it's the same network. So my question is, how many devices on the network on average provide information, and what kind of information do you provide? Can you actually fingerprint a network based on the information you're finding?
The thing here is, yes, Chrome and Firefox, I think, I don't know if Internet Explorer has features to use the wireless information that is around us to do geolocation. Sometimes your Chrome, you say, okay, I want to say, I want to know where I am. So you put the geolocation thing on your, for example, Google Map, and it's going to be able to identify you really, really accurate without GPS. So how they do that? They scan all the networks using the browser and get that information. The problem there is that the information that you get from the browser is too little. You don't get like the information elements and all this information. You only get like a little layer, like BSSID and the name of the network and some other information. So I don't think you're gonna be, I'm not sure I understand perfectly your question, but if you're saying that from a browser you're able to understand if there are HP vulnerable printers nearby or something like that, you're not gonna be able to do it because the browser, it doesn't give you a lot of information. To do that, maybe you need first to exploit something in the browser to get access to the lower APIs?
Well, let me quickly explain. What you can do from a browser is HTTP connection to any website, basically request website. So if you do that to any port of a local network, a specific IP in a local port, then something is there. The response will be slightly different if there's something that's not there, so you can detect which IP address is.
Okay.
And sometimes based on the port number, you can figure out what kind of operating system is running as well. So Windows will respond to certain ports that Linux doesn't. So it's kind of thinking that maybe you could do a fingerprinting using your technique, figuring out what IP addresses should respond because there's printers there or TVs, and then doing the same on the browser, seeing if like the same IP addresses exist in the same network.
I haven't been playing around with that, but I think it's possible to get information.
Hi, my name is Adam. Great talk. One question is, what is the future direction of your research? Are you going to look more at the protocols on the other side of the slide you showed us earlier, or are you going to go low and start looking at maybe fuzzing some of these frames and seeing if it's possible to pull out information that's stored within the firmware similar to Heartbleed?
No, I usually try to report the vulnerabilities I found. In this case, my idea is to do this presentation to get people that want to do this, because there are too much things, too many stuff to look into, and I'm not able, because I do this in my spare time, so I am able to do it. But I think there's much more things to look into. So I think that if someone is interested in doing wireless, I think that besides the known attacks that we already know that we have, you should start looking into these type of things. Because again, you buy a device or you put a device into a network, and if you don't know what it supports, okay, you are exposing your network with only one device. So I think that I will report these bugs. You mean that I was trying to report the bug? I don't understand what.
No, so basically, the next direction of your research, you can say like fuzzing and looking for potential memory disclosures at the firmware level when you send the amalgam packet.
Yes, I play around with this at my beginning of the research a couple of years ago, but then I start targeting more logical bugs, like the bugs on the Wi-Fi Direct that I explained in the latest, because they are easy to find, because they're really doing a mess, and I don't have to be like targeting low-level stuff that I have to be, you know. Besides, it's really interesting because, for example, the firmware that Project Zero found, the bugs that Project Zero found, they are really nice because in the chipset you don't have any protection. So no memory protection, no randomization, no anything. So if you gain access to a firmware exploiting some malformed information element, for example, you're going to get the whole control and really reliable exploitability on the device because there's no protection at all. Then when you try to gain access from the firmware to the kernel, maybe you are going to have a little bit more difficulties. But yes, there's a lot of things to do. This year I was targeting more logical bugs.
Well, thank you very much.